Hello, let's continue our Sudoku adventure with And My Bow by ChinStrap. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these arrows in the grid. The arrows are attached to a circle. The digits on an arrow sum to the value in the circle. So if this was 2, 3, 2 plus 3 is 5, we put a 5 in the circle. Digits can repeat on arrows as long as other rules allow it. So this we can't do 2, 2, but not because of the arrow, it's because of the box. Right? Sudoku still applies. But here we could do 1, 1, 1 and add to 3. That would be fine. All right. And in addition to that, we do have these purple lines, and they are connected to the same circles that are also used by arrows. But you can think of it as just sort of an overlapped two circles with a purple line between. These are between lines. And so whatever digits go in the circles, I'm going to ignore the arrow for a second and just do a between line example. So say this was 2 and this was 5. The digits on the purple line have to be strictly in between these two. So you can't repeat the 2, can't repeat the 5, and you can't be outside of that range. You can't be 1 or 6. So we'd have to do, say, like a 4 and a 3 here, just as an example. So 4 and 3, 3 and 4 are in between 2 and 5. So that works. What we can't do is like put a 1 here or a 6 here, repeat the 5, repeat the 2, etc. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay. How do I want to get started? There's not like an obvious place. All of these arrows, except for this one, are minimum 3. So sometimes different reasons, but the absolute minimum I can put on here is a 1, 2 pair because it's in the same box, so I can't repeat the 1. So the two smallest digits are 1, 2, and that would add to 3. So this is at least 3. This, we actually saw in the example, we could do 1, 1, 1. That's the absolute minimum we could do here. That would be at least 3. This one, again, is just minimum 1, 2, so this is at least 3. Now this, we could do 1 and 1. So this is just 2 or larger. Now, between these two, we know that these two have to be a certain amount apart from each other to be able to fit at least 2 digits in between. So we think about 1, just so we can count correctly. If this was 1, we could do 2, 3, and then put a 4 here. 4 minus 1 is 3. So these need to be at least 3 apart. So 2 digits that are at least 3 apart, one of them will be from 1, 2, 3. The other will be from 4, 5, 6. I'm just using this as scratch space. Why is that? Well, 2, 1, 2, 3s can only be 2 apart. 1, 3 is 2 apart. You can't get bigger than that. Same with 2, 4, 5, 6s. 4, 6 would be 2 apart, which means one of them is 1, 2, 3. The other is 4, 5, 6. I don't know which is which yet. I suspect this is the larger one, but I don't know for sure. Okay. So at least 3 apart, which means either this is a 3 or this is a 2 or 3. Well, there's got to be an in that I haven't discovered yet. There's a lot of contention for low digits here. So one thing I do know about this arrow is it contains a 1 or a 2. Easiest way to prove that is, well, what would be the minimum it would add to if I didn't have a 1 and I didn't have a 2? Well, it would be 3, 4, which is already 7. So we need a 1 or a 2 here. That uses up one of our low digits. We need a 1, 2, or 3 in one of these two, but not both. Here I need a 1 or a 2. I'm not sure this is helping. These, what am I trying to say? It's 3 digits. So normally, if I couldn't repeat, I would say the minimum I could put on here is a 1, 2, 3, adding to 6. But because we can repeat, we can do 1, 1, 1, for example. We can make any digit between 3 and 6, but the ways to make 6 would be 2, 2, 2, or 1, 2, 3. Those would be the ways. I don't know. Is there some reason these can't all be equal? Might be my first question. I'm not sure. Maybe there's some geometry I haven't thought about. There might be geometry with this cell here, so I'm going to call this green. I don't know what digit it is, but we're going to call whatever digit it is green. We know that it can't repeat in the column. That's Sudoku. But also, green can't go on this arrow, because then we'd have to do green plus 0 equals green. There's no 0. So none of these. You also can't put it green on its own between line or the other end of the circle, because these have to be at least 2 apart, and this has to be in between them, so obviously green doesn't repeat, which means green goes right here. And that tells us, among other things, that green is smaller than this, because the green is on an arrow that adds to it. So it has to be at least 1 smaller, which means that if green is smaller, green cannot be a 6, and this has to be at least 4, making it the 4, 5, 6, which means this does have to be 3. So what I suspected was wrong, which is maybe why I couldn't find something. And this being 3 forces this to be 1, 1, 1. All right, well, that's progress. This is 3, 4, or 5. So this could be as big as 3, but it can't be 1. So actually, this cannot be a 5 because the 1 is used. Is that right? Wait, what did I just do? Yeah, it can't be 5 because we'd have to do 5, 1, 6. So this is at least 2, and I suppose it could be a 3. No, this can't be equal to green, right? It's in the same box or row as this green, which is now 3, 4. And so if this was a, what am I saying? If this was a 3, this would also be a 3, and this would be a 3. That's bad, right? So this is actually only a 2. So we're either 3 plus 2 is 5 or 4 plus 2 is 6. So this is number 4. And this is 3 or 4. This adds to the 3 or 4. So it needs a 1, which has to go here. And this is going to be a 2 or a 3. 1 less than green. Okay. That was helpful. So this is now a 3 to 5 or 6. Now 3, 5 doesn't work because they're only 2 apart. So it actually has to be 3, 6, which makes this a 4 and that a 4 and that a 3. Perfect. And so now these are a 4, 5 pair to be in between 3, 6. That means this is a 5. That had to be 5 by the between line. And then this is a 2. Up here we need the 2 and 6. This is not 1, 2. It could be 3 or 5. It's not 6. Here we need 3, 5, 6. That's not 3. That's not 5. 6 is up here. That's not a 6 then. All right, what now? Is it about the 1s? Can we place more 1s? 1's in one of these 2, and 1's in one of these 2. So 1 is not on this arrow, so it can't add to 4. The only way to add to 4 is 1, 3. So this is 5 without a 1, so it's 2, 3. That makes that a 6, a 3, and a 5. Down here we need a 3 and 6. Oh, the 3 sees up, right? That's 6, that's 3, that's 2, that's 6. I think we're just blonking now. That's 2 and 3. Yeah, all the arrows in between lines are filled. So it's just Sudoku now. We need a 2, 4 pair. That's the 4, that's the 2, that's the 5, that's the 4. All right, this is a 5. This is a 6. Here we need a 1 and a 4. Let's just fill out these. Actually, there should just be a way to, yeah, okay. So 3 goes here. The 6 goes here. This can't be 4, so that's 1, 4, and 1. And then up here we need the 2, 4, and 5. So that's the 2, that's the 4, that's the 5. Nice puzzle, ChinStrap. It took me a sec to think about, oh, maybe I should look for geometry, and then this just sort of popped out. And that was great logic there, where this had to be less than this because it's also on its arrow, and that like really fleshed everything out. Nice. Well, let me know how you did, and if you enjoyed this, want to leave a like, subscribe, and a kind comment below.